Hello, everybody. Good evening. Um, we've got about 12 participants in the session today. Hopefully, you can hear my audio. Puneet, you just said you cannot hear my audio. Can you hear me? Am I audible?
Yes.
Okay,
Yeah.
sure. Awesome. Let me just fix a few things. Wanted to pair my Bluetooth device so I get better audio quality. Just a minute. All right. So now let me just test. I'm just connected a different audio device. Hopefully you can hear my voice now as
Yeah, it's
well.
actually a little quiet
Can I
now.
get a confirmation, please?
It's harder to hear you now.
Am I audible?
No, now it is a low voice we are getting.
Okay. It's low in volume, so now is it any better? I just increase the volume
Yes, better.
on the microphone as
It's
well.
better now.
Let me check. Okay, so I'm just picking up a little bit on the higher pitch now, so hopefully it's better. And earlier I was speaking just too low. Maybe it's better now. Yeah, Paul, all good?
Yes, it's good now.
Okay, thank you. Um, all right, so we got 12 people and we had about 9, 10, about 16 people yesterday. While we are waiting for the other participants, let's go ahead and recap what we did yesterday. And thereafter, we can circle around the table to know if you have any questions. Probably you might have done your own research, done your own labs, and I'll be glad to answer any queries that you may have. So we start with very basics of the networking concepts where we learned about the CIDR block and how that is helpful to assign a range of IP addresses in the firewall. So we used analogy of a user filling up a timesheet and how a firewall was introduced between the LAN environment, how that created issues, and how we sorted them out with the help of CIDR blocks. How ACLs are written, which is access control lists, also called as role-based access controls, or rules that are written on the firewall to allow and deny the rules or allow and deny the ports and protocols on the firewall, right? Then we created our first network in Amazon and we called it as a VPC. Thereafter, we created subnets, internet gateway. We did not create a route, but we edited an existing route and added um, 0.0.0.0/0 and then pointed that to our internet gateway, right? Thereafter, our VPC was created. We then introduced an EC2 instance, so that's where we learned how EC2 instances are created. What we created was an on-demand instance, right? We created an on-demand instance with a default image that's available in the Amazon marketplace, and they are also called as AMIs, standing for Amazon Machine Images, machine images. So we picked up the default Linux instance, and we also did a lab on Windows as well, based on a request from one of the participants. And yeah, once that was created, we hosted web application on that. So we hosted web app, and then we saw how we can edit the security groups. Yeah, how we can edit the security groups to allow port number 80 and other ports as well, right? That's what we did. Then we moved on to the concept of disaster recovery and business continuity, where we learned about new terms like recovery time objective, recovery point objective. Till what point you can get back the data to is recovery point objective, and how quickly you can get that data is recovery time objective, right? Then we looked at other aspects as well in terms of snapshots. How can you automatically DR or disaster recovery, and how you can manually trigger backup or manually triggering the snapshots. Apart from triggering, you can also recover using what we learned as CloudWatch. Within CloudWatch, you got something called as rules, which totally works like this. If something happens, do this, right? So you just have to specify these things, and there's a whole lot of options that you have inside the CloudWatch rules to specify what if stands for and what you want to do if this condition is met. For example, if the VM is shutting down, or if somebody deleted content from S3 bucket or deleted the whole bucket, what do you want to do? Well, you can trigger an alert using SNS, or maybe take a snapshot of the volumes, right? Or back up the content to Glacier. Well, there's a lot of options that you have inside both of these sections, which is if and do inside the rules, right? We ended the session with certain Q&A, questions and answers, and we left for the day and got a good sleep. We are here again, and today we'll be talking some more about disaster recovery. However, we'll be using new service offerings from AWS, which is called as AWS Storage Gateway. And AWS Storage Gateway is tightly linked up with S3. So we should also understand what S3 is. It's also important to understand the networking concepts of these. So we'll deep dive into the architecture of AWS Storage Gateway. What are the various options available inside AWS Storage Gateway? How does AWS S3 work? How do you integrate AWS S3 with Storage Gateway? Whenever you hear this term called as gateway, it just means that this is an endpoint of your network, right? Like internet gateway. The internet gateway is a gateway for the data traffic that is getting in and out of your network, right? From the whole network. So the data that is going out of your network hits the gateway, and from there on, the traffic is sent either to the on-premise or to the internet, right? So that's what a gateway is. Now here we're specifying storage gateway. That means the storage components of AWS like S3 or Glacier or block storage will be connected to your on-premise with the help of an endpoint device called as storage gateway. The storage gateway is primarily used for data in transit, or data that is in motion, data that is moving from point A to point B. You will need a storage gateway, and organizations specifically use this for creating an on-premise to AWS cloud hybrid connectivities. So if you would like to have storage on your premise in the form of SAN, NAS connected to AWS S3, what you will need in the intermediate section is a storage gateway. So this is just introduction to what a storage gateway is. There's a lot of things that we'll talk about, including the deep dive of storage gateway and architectural diagrams that I'm going to show, or maybe draw on MS Paint, so that we can retain these things for a longer time. These two will be done cumulatively in a lab. So we will have a full end-to-end lab setup for this. Let's see how that goes, provided I have blessings from demo gods today. So it's a lot of blessings we need from demo gods to have a proper demonstration. Now, what else are we going to do? We will also talk something about networks. You and I know that VPCs is not the only thing. Okay, got a message. Reduce the volume of your headphone. It has a little bit noise. Okay, I don't know, how do I reduce the volume? What kind of noise do you get, Amod? Is it like somebody talking in the background, or is it
No, kind
some
of
kind
a
of
crackle pop.
buzzing something? What is it?
It's your voice is cracking. It happens when the
Me, or is
Bluetooth,
it
the
someone
volume
who's
is
not
cracked.
muted? I'm not sure. Or is everybody getting that noise? Then it's from my side.
Yes. Yes, your voice is
So,
cracking.
Akhil, you're getting that noise as well?
Yes.
Slight reduction in volume. Okay, probably. All right. Now, just reduce the volume like that. Okay. All right. So, great. Awesome. So, thanks for figuring out the problem and giving the solution as well. What else do I need? Great audience. Thank you. Thanks, Paul. So if where was I? Where was I? Okay, networks. So I was talking about networks, VPCs. So yeah, there's a lot more than VPCs. VPC is just a very basic component which we just created yesterday. Today we will see how you can create something called as a jump host, and how you can do a NAT gateway. Answering the question in the chat, which says, can you please share all the training videos in one shared drive location and share the link? So yesterday, Akhil, I shared a link. Do you have it? There is a folder called as day one inside the link that I shared. And last night, it took about 3 hours to convert that video to MP4, and it's uploaded in the same drive in the day one folder. So once I get access to my drive, I will share that again. Don't worry about the materials, I'll be giving that, but at this time, let's just focus on the core subject here. Thank you. So this is the agenda for today. Storage gateway, simple storage services, which is S3, configuring a jump host, or also called as a bastion host. Some people put S right there, yeah. Bastion host, or how do you use NAT gateways in AWS? That's the agenda for today. So that way we'll be covering a couple of things. One is disaster recovery, storage. There is encryption sitting somewhere in the middle, which is encrypting the data at rest and data in transit, securing your networks using NAT gateways and jump host / bastion host. So we are still aligning to the course content that we discussed yesterday. None of this is going beyond or less than the course or beyond the course. We're still sticking to those bullet points mentioned there. Now, point number one, which is storage gateway. So start making notes just like what I did yesterday. So you do not have to make notes. and all you got to do is just listen and focus and have patience. Let's understand the concept of storage gateway. What is a gateway? We just discussed that a minute ago. It connects on-premise appliances with cloud-based storage so that it gives you a seamless integration with data security features between your on-premise IT environment and AWS storage infrastructure. So we're defining the term storage gateway specific to AWS here. So we just said that if we are connecting on-prem with the storage in AWS, what I need is a storage gateway. And this storage gateway will let me transact data securely between on-premise and the cloud. So you can seamlessly integrate your on-premise IT environments with AWS storage infrastructure. I'm just talking about storage here, not about VPCs or any other infra or even RDS. So you can use this service called as storage gateways to store data in AWS cloud. Oops, that's bad. Sorry, AWS. AWS cloud for scalable and cost-effective storage that helps maintain data security, right? So data is transacted to and fro from on-premise to the cloud, and that is done securely. So now AWS comes with different solutions just for this thing, because one size does not fit all, right? So just like that, the storage gateway is not a solution for all kinds of storage devices, because on-prem you got a NAS storage, you have a DAS storage, you have a SAN storage, and hence Amazon came up with 3 different solutions. And these 3 solutions are being offered by Amazon. They are the solutions offering as on today, and they call it as file-based storage gateway. Second one is volume-based storage gateway. And the third one is tape-based storage gateway. Today, in most of the discussions that we're going to have today, it will be revolving around these 3 items: file-based, volume-based, tape-based. In fact, we'll also be doing certain labs. So once we do labs, your hands will get dirty and we'll remember or memorize for a longer time. So what is a file-based gateway or a file gateway? Okay. Starting from a file gateway. A file gateway, how about using short terms now? Okay. I don't want to be lazy here. I'll put the full thing. A file gateway supports a file interface into S3. So it creates an interface between on-premise and the cloud. And when I say cloud, specifically S3, so it connects to S3. And what you need is an interface. And this interface is a virtual machine. Let's call it as a virtual appliance. So when we're drawing this, connecting on-prem to the storage, we are saying you need a storage gateway, and this time it becomes a file storage gateway. So let me just copy the whole thing, scroll down and paste it here. And now I'll say it is a file storage gateway. Okay. Okay, keeping it simple. And this is specifically S3. Okay. The balloon on the chat is popping here. Is it needed at both ends? You do not need the gateway at both ends. What you will need is a gateway just at the on-premise side. A gateway is here. In this case, specifically the storage gateway is on-premise. Now, this storage gateway is a virtual appliance. Like I said, this is a virtual appliance or a virtual machine. You can store, retrieve objects into S3. I'm saying objects because S3 is an object storage. Now your question may be, what protocols is it using? Well, it is using industry standard protocols such as NFS and SMB. You have the choice. When you're creating the appliance, you have the choice as to how you want the data transaction and what protocol it should be using. Is it NFS or SMB? The software appliance or gateway is deployed on your premise. Now, this is deployed on your premise. And this is a virtual machine. This virtual machine can be running on VMware ESXi or Microsoft Hyper-V, or it could be a VM running on EC2 instance. It is not necessary that all the customers who are using AWS have an on-premise infrastructure. If I'm a company with a single user, well, let's say I have an organization and I am just a single user who does all the work, and I want to have a private communication between my laptop and S3, and I cannot afford a VMware ESXi license or a Microsoft Hyper-V license because I'm a one-man show, I will go ahead and provision an EC2 instance that will then act as a storage gateway, right? So this storage gateway, I'll start writing short forms here. A storage, well, I think I should put storage gateway here instead of SG, because SG stands for security groups. Okay, storage gateway. So this storage gateway will give you access to the objects in S3 as files or file share mount points. That means you can mount it as a drive on your Windows machines, on your Mac machines, and Linux machines. So basically what happens here is that we deploy a storage gateway on premise, and that data storage gateway will get access to a file share. Now, whatever we create in that file share, or if these servers on premise, if they write some data to that file share will just convert those files into data in S3 bucket. So the main component here is the file gateway itself. And now you can have the storage gateway be up and running as a virtual machine on a physical server on premise, or it can be deployed upon an EC2 instance. With a file gateway, you can do the following. We'll just make a note of it. Number one, what can you do with a file gateway? With a file gateway, you can store and retrieve files directly using NFS, or let's put the version number as well, which are supported as on today. They will support NFS version 3 or 4.1 protocol. Second, you can also store and retrieve files using server message block, which is SMB, and it's recommended that you do not use version 1. Use version 2, and that's going to be deprecated pretty soon, so use version 3, but both version 2 and version 3 are supported as on today. And the third thing is that if you do either of these, point 1 and point 2, you can access your data directly in S3 from any cloud-based applications. And these cloud-based applications can be hosted anywhere, can be just anywhere. Because it's a gateway, and gateway will have a public IP address. Okay. So you can manage your S3 data using a live set of policies. You can do cross-regional replication. So you can think of a file gateway as a file system mount point, and that mounts to an S3 bucket. Is it clear? Any questions, please?
Yeah, the question is, S3 is a object storage. So how come this storage gateway it is getting mapped
Was that
to the
confusing,
file?
guys? You guys okay? Okay. All right. So questions on the chat? Yeah. Okay, sure.
And also this S3 is
No, I couldn't hear
accessible
you.
anyway from anywhere.
Probably let me increase my volume. Just increase my volume. Yeah. Um.
So, I mean, don't we get access for S3
Yeah,
objects to
I
be
see that.
accessible from public or any other location without
I see
using this
Amit
file
has
gateway?
unmuted. Probably Amit is asking a question, but I cannot hear. So let me quickly check my audio stuff. What's going on? Yeah, mic sound check. I'm doing a sound check quickly. Apologies for this. Should have done that earlier. No, I don't hear this. Mic works good. Yeah, this is not good. So here's what I'm gonna do. I will get rid of the Bluetooth and come back to disconnect and turn off the Bluetooth. Right. So Amit, I think you were asking the question. Can you hear me all right? And if yes, please try talking one more time.
Can you hear me now?
Amazing. This feels so good, man. Please go ahead. Thank you.
Yeah, I was saying about the S3. So objects in S3, you can always make them visible or accessible by giving them access to be, like public access or some use some other kind of access you give. So what is the need of this file gateway in that scenario?
Hey,
And
very
you
quick.
said that one more question. You said that this gateway is at the customer premises, but if it is an appliance at EC2 in a EC2 instance, then this will be a AWS location, not the customer premises.
So you got two questions. Question one is that AWS S3 is accessible over the internet anyways if you make it public. Second question is that I was contradicting my own statements when I said that, hey, the storage gateway must be on premise. But when we create an EC2 instance, it is in AWS. So what exactly does that mean? All right, so AWS S3 is accessible over the internet on HTTP and HTTPS, right? Okay. Second, the S3 buckets cannot be mounted as a volume on on-prem or even on cloud-based instances. However, there are third-party tools that will let you do this, but AWS by default has not given us any mechanism to mount it as a volume on your premise or cloud. If there are any applications that truly need the power of SMB protocol and NFS, so you can mount S3 as a NFS mount point, then you need a storage gateway. You create a storage gateway, connect the S3 to the storage gateway, and then you can mount this storage gateway on your premise or in a different cloud as well. Does this answer your first question, Amit?
So, if it is mounted as NFS, so it will give you the access to all the directory structure. I mean, the structure it has, or the only one object. If it is mounted as NFS.
You will be mounting the bucket. You mount the bucket.
Okay, so all the underlying objects will be accessible by NFS.
Yes, true.
So in other terms, storage gateway acts as a NFS export, and the storage gateway internally communicate to S3 volume, right?
Right. So storage gateway is responsible to convert the block content to an object content. Yes,
Okay.
it will help you mount it.
So, okay.
Rohit, does that answer your question as well? Because at one point I did say that it will help you convert the data.
But yes, Anand.
Okay. So the file share will just convert those files into the data in the form of an object storage in S3. Coming to the second question about EC2 instance in AWS. And at one point I said that not all customers of AWS will have an on-premise infrastructure. Let's just say that I'm a startup company and I do not have resources, right? I do not have a whole lot of content. All I have is an external hard disk that I connect to my laptop to copy all my patents and my intellectual property. But at the same time, I'm worried about my business continuity, and hence I focus on disaster recovery. And something happens to my hard disk, I don't want to take that chance. So also, I do not want to create virtual machines on my premise because I really cannot afford it because I'm a startup. So for such purposes, Amazon gives you the flexibility to create an EC2 instance and use that as a storage gateway. You can have a storage gateway on-prem. So if you got a large infrastructure like yours, you're all working for NTT, you got a large infrastructure, you will not have an EC2 instance doing the job of a storage gateway. You will have an on-premise virtual machine, and that virtual machine can be on Hyper-V or VMware ESX. And if I'm a startup, I really cannot afford all that big terms like VMware and Hyper-V, so I'll go for an EC2 instance. But if somebody asks you, what is the position of a storage gateway in your network architecture? It is on-premise. Unless I've got nothing or I have nothing defined in my on-premise where I've got just my laptop as an on-premise device. Yeah?
And can you hear me?
Yeah, I can hear you.
So since now we have some somewhat understanding about storage gateway, so would you please summarize once again what you told so far, so that then it will easy to understand everything, because so far whatever you was telling, we were just imagining this can happen, but now we have somewhat understanding. It will be easy to understand if you summarize once again.
Yeah, I'll just summarize that in few words here. Here I've got my on-premise, right? I got my on-premise, and what I will then have is maybe if I want to have data transactions in encrypted fashion securely over private network, and then transact all the data from on-premise to S3 storage. I will have one device doing all of this job, and that device is nothing but a file storage gateway. So a file storage gateway will let me do all that good stuff, which is transacting the data securely between on-premise and the storage in AWS, which is S3. You can push any amount of data on your premise, and storage gateway will take that seamlessly, and it's a cost-effective storage. And since there are different kinds of storage that people usually have on their premise, Amazon has made 3 different solutions or 3 different kinds of storage gateways. So one is file-based, second one is volume-based, and third one is tape-based. And we were talking about file-based all this while. And file-based is where I'm just using a storage gateway, let's say an EC2 instance or an on-premise Hyper-V or a VMware ESX instance as a storage gateway to transact between on-prem and S3 storage. Okay,
Okay,
is that
thank you. Okay. Okay. Is there any other advantage of using storage gateway or any other application, like in terms of DR? Can we use it for DR purposes as well, or is it can only be used just as a block storage or just for transferring the data online into S3?
this is kind of a DR setup. This is a DR setup where I have data in the cloud, I have data on premise as well. So just in case things go wrong, I will have the data available in the cloud storage. And then I can have geographical replication set up between one S3 storage and another S3 storage, just in case if you want additional DR plan. In the next section, you will also see how we can improve the performance. So we are focusing on one part of the pillar of the well-designed architect, which is resiliency, and this whole setup is creating good amount of resiliency there. But if we configure it in a better way, you can also have better performance, which will then hit the second pillar of well-architected framework, which is performance. But we haven't reached there yet. Till this point, we were referring to and talking about just the DR section, where I have a very basic setup, created a storage gateway between on-premise and the storage in AWS called S3, and data just asynchronously gets replicated from point A to point B, point A being on-prem and point B being S3 storage. And because we are using industry recognized protocols like NFS and SMB, NFS for Linux and Unix machines and SMB for Windows machines, there's a very high level of compatibility for the operating systems as well, and it can be used for any heterogeneous environments. Okay?
Okay, thank you.
Thank you. Moving ahead, we just spoke about, where was I? Yeah, file-based. I'm jumping to volume-based, and we'll be touching upon file-based one more time, where we'll be talking about the architecture of file-based. But for now, I'm just giving you an overview of each one of them, and then we'll get into the architecture of them one by one, and then we'll do the labs. For now, I'm talking about a volume-based, or just a volume.
Hey, Anand, sorry to interrupt you. I have one quick question. Like for the file-based storage, can be mounted as a drive in the EC2 instances?
Yes, you can.
Okay, thank you.
Let's do that in the lab as well, so that way you'll get a clear picture. We'll do that in the lab, because I tried to do it on my Windows machine. I could not, because my Windows does not have the command called as mount. CMD, if I type mount, I don't have the command basically. So even I tried to install the Linux utilities for Windows, but it's not available for my version of Windows because it's a Windows Home Edition. For Enterprise Edition, it is available, so I just left it there. But it's a good idea to test it on an EC2 instance on the cloud, and we'll give it a shot. Okay.
Thank you.
Thank you. So volume storage gateway. What is a volume storage gateway? A volume storage gateway will give you cloud backed storage volumes that you can mount with iSCSI. iSCSI stands for Internet Small Computer System Interface. So if you got any devices on your premise which are compatible with iSCSI devices or iSCSI transactions, then volume storage gateway is best, because file storage gateway understands just SMB and NFS. So what is a volume storage gateway? A volume storage gateway will give you a cloud-based storage volumes which can then be mounted as an iSCSI interface on your premise application servers, right? So volume storage gateway is letting you create volumes of iSCSI nature that can then be mounted on prem devices or on-prem app servers. So now the volume storage gateway is of two kinds. Amazon is thinking a lot in these lines in terms of performance, in terms of resilience, so they are getting further into it and saying that volume storage gateway can be configured in two configurations, or just put two configurations. Number one, you got cached volumes, and the second one is stored volumes. Starting with cached volume. What is a cached volume? With cached volume, you store your entire data into S3. However, before storing that, you retain frequently accessed data locally. So that will clearly increase the performance, isn't it? Because you're creating a cached volume will offer you a substantial cost saving as well, because your primary storage is still in the cloud, but you're increasing the performance because your cache is somewhere local, which is frequently accessed data is stored in local data centers, and that minimizes the need to scale your storage on premise. You also retain low latency access files to your frequently accessed data. Anything that you think is heavy duty and intensive in nature will also be stored in the cached volume on your premise. The main concept behind the cached volume architecture is that the entire data, everything end to end, stays in S3. I'll put S3 buckets. And you retain frequently accessed information on your premise. So on your premise, if there's somebody accessing that on your premise, you will have a better IOPS. The second one is stored volumes. What is a stored volume? If you need low latency access to your entire data set, first configure the on-premise gateway to store all the data locally, and then asynchronously backup point-in-time snapshots of data to S3 buckets. So the difference here is pretty big. The difference is that in cached volume, you got everything on S3 buckets. In stored volumes, you got everything on your premise, but you will have snapshots of data in S3 buckets, not the whole data. So you configure your storage gateway as a stored volume and store everything there, data locally on your premise, and then asynchronously, it's important, it will be transferring that asynchronously backup point in time snapshots of data will be transferred to S3 bucket. So this configuration will give you durability as well as inexpensive offsite backups, because snapshots are always incremental in nature, and you can recover your local data center, recover your Amazon EC2 instances. For example, if you need a replacement capacity for disaster recovery, you can recover the backups to EC2. So in a stored volume architecture, you store the entire data on your premise and you asynchronously create point-in-time snapshots that are being backed up in S3 buckets. That's the difference between cached and storage. Any questions?
Can you repeat once again for stored volumes? I'm not completely understood. Sorry, but
So stored
please.
volumes, you're gonna keep everything on your premise. And with the help of the storage gateway that is configured as stored volume gateway, it will take snapshots of your virtual machines and snapshots of your data, and then put those snapshots in the S3 bucket. So I would say you have your on-premise production environment running on your premise, but the backups are actually happening, or incremental backups or snapshots are happening on AWS. They are stored in S3 buckets. So at any point in time, you would like to restore the virtual machines running on your premise, you can use the snapshots which are stored in S3 bucket, as opposed to cached volume, which means that it's gonna store everything inside S3 bucket, and stored volume does not do that.
So, Anand, what is the practical application of a cached volume?
Increasing the performance of on-premise applications. If I got applications on-premise, I would go ahead and cache the frequently accessed data. I will have analytics running. If you heard of Google Analytics, then I will have one of those analytical applications. Analytical, what is that? Apps, specifically Google Analytical apps, or Azure Analytics, or AWS does not have any such applications today, but there is one from Azure. You can run one of those, and that tells me which files have been accessed frequently, and I can write a rule and say that, hey, let's not sync up all of these files, and I will have just the data that has not been accessed frequently that will go into my S3 bucket. And you know that S3 bucket has different storage types, and I will have the content going to what kind of storage type? Infrequently accessed data, right? So there is definitely a cost saving out there. On my premise, I'm not storing everything, right? I'm storing just what's being accessed by my employees or by my customers, and I'm syncing everything else to S3. And there I've chosen a cheaper storage class. This is a storage class, which is infrequent access data storage class, and thereby I'm reducing my costs, isn't it?
Yes, that is clear. Thank you.
Hey, sounds good. Thank you. So all in all, AWS Storage Gateway.
Since in stored volume, since it is also iSCSI, and you told the data has to be stored locally, so it seems to be contradicting because in iSCSI the data should be in S3, right? Just like cached volume. So how we can set up this thing that the data has to be stored locally in data center, and it will be taking snapshot to the stored volume over iSCSI? Because then there will be two storages. One is coming from S3 and another is stored, another is lying in my local data center, right?
Are we pointing to stored volumes or cached volumes?
Yes, stored volumes.
Stored volumes. In stored volumes, I'm just taking the snapshots, not the whole thing, just a snapshot, just in case I ever need it. Let's say my on-premise hard disk is gone, then I can get snapshots from AWS S3 because they are incremental snapshots.
So stored volume is also iSCSI, right?
It is iSCSI, yeah.
Or not?
It is.
So how I set this up to take a snapshot, I mean, of my local hard disk? I understand in cached volume it is iSCSI inside operating system or wherever in VMware level. I can use iSCSI initiator tools to get access to this iSCSI storage, right?
Mm-hmm.
So how to do same in case of stored volume? I mean, how I can take a snapshot of my hard disk into the stored volume? I'm just thinking of practically from lab environment perspective.
So the storage gateway is the one that is responsible for taking those snapshots at periodical intervals. So if you point it to a particular virtual machine and say that, hey, you take a snapshot, it will be scheduled at that point in time. Just like what we did yesterday, we configured a snapshot for an EC2 instance using rules in CloudWatch. But here, if you define the storage gateway as a stored volume, it does that automatically based on the time intervals that you specify on the storage gateway itself.
Okay, so this has to be done on the storage gateway side, not on the host side, on the local storage side.
It is, yes.
Got it. Okay, thank you.
So the volume gateway, regardless cache or storage, is more from the block storage and not from object storage. Both of them are object storage because it is using the iSCSI protocol. Data that is written to these volumes, like I said, they are asynchronously backed up as point-in-time snapshots. And they are stored in cloud as EBS snapshots, which will then go into S3, and all the snapshots are always incremental. There is a scheduler service as well, talking about how and when. So you can back up your on-premise volume gateway volumes using a service called as AWS backup service. You can schedule that. In both the cases, volume backups are stored in EBS volume snapshots regardless. And in order to reduce the cost of storing the snapshots, Amazon by default compresses. So all snapshots storage is compressed to minimize your storage charges. You can customize the schedule backup policies to match your backup requirement, your retention policies. You can set up backup retention and expiration rules as well. So when you no longer need to develop custom scripts or manually manage the point-in-time backups of your volumes. You can also manage and monitor backups across multiple gateways and other AWS resources from a central point. So there are multiple things. It's an integration of on-premise to S3 via the storage gateway and EBS, and then you integrate with AWS backup service further to customize your scheduled backup policies and set up the retention and expiration rules of the backups or as snapshots. Was that clear? Hopefully there's no confusion left.
Yes, sir. I got my question answered.
Hey, thank you very much. With that, let's go ahead and discuss about tape. Did I say backup? No. Tape gateways. Finally, this is the last one in the storage gateway section. And with a tape gateway, you can cost effectively and durably archive backups, or let's say backup data in Amazon Glacier. I'm introducing another service here. So I'll go back to this thing, Glacier. Wow. So the first two storage gateways, which were what? Volume and there's another one, volume and file based. They are connecting to S3 buckets directly or indirectly. File based is connecting directly, whereas volume based is connecting indirectly via EBS snapshots. Tape gateways is not connecting to S3, it is connecting to Glacier, because Glacier is used for archival purposes and long-term retention of your data. So tape gateways are archiving solutions. They connect to your on-premise and then back up or take archives on the Glacier. Now what you need is a similar infrastructure here. A gateway, or rather say a tape gateway, provides a virtual tape infrastructure, not real, but it's virtual tape infrastructure that will scale seamlessly with your business needs and eliminates the operational burden of provisioning, scaling, and maintaining a physical tape library or physical tape infrastructure. So to that tape gateway, you establish a virtual tape infrastructure, and the entire data is being saved to the virtual tapes, and they are being backed up by S3 again. You can archive these virtual tapes in the form of virtual tape shelf that's being backed up by Amazon Glacier. It's always recommended that if you want to have long time archivals, we always use Glacier and not S3. Although S3 has different storage classes like frequently accessed, infrequently accessed, which is standard, infrequent, single zone, RR, as reduced redundancy. You got several of those storage classes in S3, but it's recommended that if you would like to archive and backup for long-term retention, you keep it in Glacier, because Glacier is far, far cheaper than S3. But that doesn't mean that you start taking information from Glacier every other day. Or if you do so, then the cost of storing in Glacier will just be exponentially high. So you
For farming, The restore times on that is also much greater, right? Doesn't it take longer to access those?
Agreed. Yeah. If you have data in Glacier, it takes longer time. Earlier, a few years ago, it used to take about 6 to 7 hours to prepare the data and keep it ready for restoration. But Amazon has understood that it's a big problem area, and the recovery time objective is increased very much. And a lot of organizations, specifically banking, healthcare, governments, if they would like to choose Amazon's Glacier as their archival solution, they will just turn away and show their back by looking at the recovery time objective. Amazon learned lessons from that and has reduced the recovery time objective to 1 to 2 hours depending on how much the data is. So today we are working on an advanced Glacier, or maybe some Glacier and steroids probably, which can have a reduced RTO as opposed to what was earlier. Okay, now what next? Let's discuss about the architectures of these different types of solutions. And of course, there's a lab session, and I'll show you how do you create and configure your file gateway. But let's take a look at the architecture of file gateway. Architecture of file gateway. Hey, Senthil, just sent a hi there. Hi, you got a question?
Yeah, I just joined today and I missed the session on yesterday also. So I thought if I can discuss everything later. Yeah.
Sure. Yeah. Welcome to the session. We are just focusing on the advanced concepts of AWS. All the sessions are recorded. The notes that I'm making will be uploaded to a common Google Drive, and you will have the Google Drive link in the chat that Paul shared a few minutes ago. So you may want to scroll up and find that link. All the material is there, including the video conversations that we had yesterday.
Excellent. Excellent. I just able to see that previous conversation history in the chat window. Probably I do not have the information, so I'll double check. Thank you so much.
There you go.
I got it now. Thank you.
Thanks, Paul. All right.
Sure. Now we can proceed, please.
Thank you. So now, so far, we just focused on the basics of storage gateways. Now, it's important that we move forward and start understanding how storage gateway works for you. So we'll deep dive in and understand the entire architecture. We started with file gateways initially, and then we went to volume, and then finally the tape drives, understood the purpose of it. And now we'll be understanding how do you configure it. What are the different pieces that make it a file gateway? So the very first thing that we do is that we activate a file gateway. And we know that this gateway is a virtual machine, regardless. It could be a VM on your premise on a Hyper-V, or VMware ESX, or an EC2 instance. Now, once you have the EC2 instance up and running, you activate the gateway. So step number one is to create a gateway, which is nothing but a VM. And this VM will have a public representation, which is in a public IP. So when I create my storage gateway, I will point it to the public IP. And tell that my AWS Storage Gateway is the following VM by pointing it to the following public IP. Right? Then you also connect an S3 bucket to the storage gateway. Thereafter, what you get is a mount point, which can be mounted on Mac, Windows, and Linux. and it gives you all mount commands. And it will give you mount commands because you have configured the storage gateway as NFS. If you configure it as SMB, you may get net use commands, but let's just stick to one of them right now, NFS. Then you will use mount commands to mount that volume. So you have to create and configure your file share, associate that share with your S3 bucket. Now the file share is a major component of this entire architecture. Doing this will make this share accessible, but just by the clients that are using NFS or SMB, not both. Because I cannot configure a storage gateway with both NFS and SMB. It's NFS or SMB. So this file share will be created and configured, and it will be associated because you mapped it to your S3 bucket. What happens is that all your on-premise application servers or clients will be able to write the data to this file share using NFS or SMB protocol, and that data is being converted into the objects and saved into your S3 bucket. So the files returned to the file share becomes objects on S3 with the path being the key. There is a one-to-one mapping between files and objects, and the gateway updates the objects in S3 asynchronously. So whenever you change the existing files, they are then modified on the S3 bucket as well. But the main thing that you have to understand is that you have to activate.
One question. You keep on saying asynchronously. So could you please emphasize on that? How it is differ from synchronously? Will there be any delay in updating the data on S3 or not? And second question, one more question. Will it also retain the permissions, like on file share, if I make any permission changes, or how the permission would be if on a NFS port from a gateway?
Okay. Synchronous versus asynchronous. Synchronous will happen, or any replication that is synchronous in nature will happen right then and there. The send receive operation, the data that is being modified at point A will be modified at point B immediately using synchronous replication. But using asynchronous replication, it doesn't happen like that. It will take a while to store that. The metadata and references will then be updated, and then the data gets transferred. There will be a latency, but the latency is not that massive. And again, it depends on how far your data is. If your on-premise data center is in California, and if you got your storage gateway sitting somewhere in Singapore, then yes, you will see a delta. You will actually feel the difference. Usually people do not do that. They will have the storage gateway sitting in almost in the same geographical location. It's one of the recommendations as well from Amazon. They say that your storage gateway must be in the same location or closest to the location where your on-prem is. There was a secondary question as well. Synchronous. What's the second question, my friend?
It was how the permissions will respond and how they are retained, because the data will be ultimately transferred to a S3 bucket, which doesn't maintain NFS permissions, right? So I just want to understand, or I want you to shed more light on that. So how the permission would be.
So here's what people usually do. People will use SMB and then integrate that with Active Directory. And when I say Active Directory, they integrate that with on-prem Active Directory. In Azure, there is a in AWS, there's a specific component called as AWS Directory Services. So there is a way you can sync between on-prem directory services or Active Directory to AWS Directory Services. And this is one of the prerequisites if you would like to have the file share permissions propagated to AWS S3 bucket. You need to have that. Till that point, you'll just get files, shares, but not their permissions.
Okay, and what about in case of NFS?
Yes, so NFS, as you know, is Unix and Linux platform. It is supported in Windows as well, but not on all Windows platforms. Specifically for home editions, it is not supported. So if you have the NFS client installed on Windows, yeah, you will have those permissions propagated as well. But this directory services comes in two flavors there. Windows, it comes in two flavors. There's Windows version of it, and there is a Linux/Unix version of it as well. So in AWS, when you create directory services, it asks you what kind of directory services do you want. Is it Windows 2016, 2012, or Unix? And this is more mapped, or this works great with NFS permissions.
Okay, thank you.
Thank you. Okay.
Sorry, I keep interrupting you in between, but I might be because whenever I have doubt comes in my mind, I ask it immediately, because if I maybe I will forget it about later. So sorry about that.
I really appreciate all the questions that we as an audience get together. I know how to get back to this. And if I'm not able to get back to the point, maybe you are here to help me out and say, hey, Adam, this is what we're talking about. But there is no point keeping the question in the head and lingering in the head for a long time, because you'll not understand the next, or maybe may have difficulty understanding the next one. So always feel free to interrupt that in the chat, stop me and say, hey, Anand, stop right now. And that way it's beneficial for all of us as a group together. I'm not saying that I know everything in this world, but if I don't know something, definitely I will refer back to the books and come back to you tomorrow. Thank you. Thanks, Rakesh. So now help me, where were we? So so we were here, NFS mount. So we spoke about activating the file gateway. We created the EC2 instance. Yeah, so we'll have the shares accessible using NFS or SMB. So this file share will be created and configured, and it will be associated or mapped to your S3 bucket. Right? This is where we're talking about. So now what happens? Now what happens is that all your on-premise application servers or clients will be able to write the data to the file share using NFS or SMB, and that data is, like I said, eventually it will be converted into the objects and saved into your S3 buckets. So the main thing we have to understand is that you have to activate your storage gateway, then you have to create and configure the file share and map that file share with S3 bucket. The clients in your data center will write the data to the file share, and that data will then be converted into objects in your S3 bucket. Now, probably I'm repeating the whole thing again, but let's move on. Let's talk about some of the features of file gateway. You may talk about encryption, because encryption is one of the key focus area of AWS professional certification, specific security, distributed denial of service, encryption for the data at rest, encryption for the data in transit. These are the bullet points that the blueprint has. So let's talk about it. So one of the key features for file gateway is that objects are encrypted with S3, with Amazon S3 server-side encryption keys. All data is transferred using HTTPS. That means it uses a certificate to encrypt the data being transmitted to the S3 buckets. The server will optimize the data transfer between the gateway and AWS using multi-part uploads. So if you got a lot of content being uploaded to the S3 bucket, it will use multi-part uploads where your data will be split into multiple smaller blocks, and when those blocks arrive in the S3 bucket, they'll be stitched together in that order. And that is done in order to optimize your bandwidth or better utilize bandwidths. Right? Remember that there is a local cache that is maintained to give low latency access to the recently or frequently accessed data. So what happens is that the storage gateway it actually maintains a local cache, so that any of the data that is being accessed frequently would be kept on premise. And you can definitely integrate CloudWatch metrics that will give you an insight into the resources usage on virtual machines and the data transfer to and from AWS. So Cloud Metrics will do the insight of the usage. They'll also tell about the network utilization during transfer, right? And also, if you configure it further, you can also have the data being transferred, latency for the applications. They can be configured. And there is another service called as CloudTrail. CloudTrail is primarily used for auditing purposes. So we can have CloudTrail through which you can track all changes done by users or humans, or if they have been done using API calls. Is this clear?
Yes.
I'm going to quickly pick up diagram here, so that way you understand this better. I'm just trying to search for the diagram in one of my documentations. So here we go, and got that right here. It may be pixelated if I expand this, but okay. So yeah, at least people can see this. There you go. It's better. All right. So what's going on here? You see on the left hand side, that is your on-premise or the data center or the customer's premise. And on the right hand side is your AWS infrastructure in the cloud. On the customer's premise, you got the storage gateway. And we also create and configure the file share. these servers in the data center right here, these servers, which are application servers, will write the data to the virtual file server or the file share right here within the storage gateway, and using SMB or NFS, the data is being written to the storage gateway. And then it is pushed from the storage gateway all the way to the S3 bucket. Now this data transfer can happen over the internet. And if you do not want this to happen over the internet, you can have VPNs, or you can use something called as a direct connect, which will give you an encrypted connection with higher bandwidths. VPNs are known for their notorious bandwidth. They're pretty bad in bandwidth, so people complain, applications will complain, application owners will cry about it if you have VPN. So we'll have direct connect, which will give you about 10 Gbps or up to 10 Gbps of bandwidth, which is massive. So you can use a direct connect to connect from your on-premise to the cloud, and then use storage connect to have the data transaction happen between storage gateway and let that push the content to S3 bucket over the direct connect channel. So now the data transfer can happen over the internet, or you can have a direct connection. So what you do is that you push the entire data from the file share to the S3 bucket, and that data has been saved in the form of objects. And of course, you can archive into a different storage class. So you can write life cycle policies on S3 bucket and say that, hey, if the object is sitting in my S3 bucket for about 30 days untouched, then let me move it to a cheaper class storage, which is S3 infrequent access. And then you can write another rule and say, if the object hasn't been touched and it's still sitting there for over 90 days, then let me move it to Glacier, or maybe delete it after 360 days. So these are the life cycle policies that can be written on the S3 bucket. So this is the architecture of the file gateway. Please let me know if you have any questions before we break for 10 minutes, and then we'll come back and talk about the architecture of file. I think we just did file gateway. So we have to talk about cached volumes and storage volumes and tape-based structures. It's been an hour and a half. It's difficult for all of us to focus as well for long durations. Unless you have any questions, I'll start the timer now and we jump off the seat to get the coffee.
So the storage, whatever the app server stores, say some file and all. So first it goes to S3, and after some time it went to Amazon Glacier. So if the app server requests that file, will it directly map to Amazon Glacier for recovery?
No, it does not. It does not directly map to Glacier. It is we who have to restore it from Glacier to S3, and then the application will point it there. If you have if you have the policy written that says let me move the object from S3 to Glacier, application server will not know, because Glacier is primarily meant for long-term archival purposes.
So this will be kind of manual exercise that you have to do.
If we have a rule written that says that the object must go into Glacier after 90 days, the probabilities of using that file is low if you haven't used that file for over 90 days. Yes, it is a manual. Yes, it is.
That's fine. 90 days it is not used. But what if the request comes? So maybe some audit or something XYZ issue, but the requirement comes. So this will be how will this happen? Who will do it? How one will come to know that this is to be done?
So the object from S3 goes and sits in Glacier. The moment you need it, you do it manually. You launch the Glacier tool. Well, there is no Glacier tool from Amazon as of now. You use a tool called as, what's that, Fast Glacier? Yeah. So you can use Fast Glacier to connect to Amazon Glacier, and then it can pick up. So actually it's failing for me because I do not have the access keys defined, which is okay. But I'm just showing you the tool there. I can use this Fast Glacier tool to restore it, download it, and then upload it back to S3. And then application can then look at the content one more time. Remember, whenever there is a manual activity, it means that it probably is a one-time effort, once in 90 days or once in 180 days, which is okay. You would like to automate the things which are done frequently on daily basis, not things like restoring from a glacier, which are not done on daily basis. And if you would like to restore on daily basis, then Glacier is not the place to store the data because bills will be just too high. I want to use maybe infrequent access if you like to move data back and forth between on-premise and S3. I'll use S3 or S3 infrequent access.
So infrequent it can recover, or infrequent also is manual.
Infrequent, the metadata will just remain the same. It's just the storage class that has changed. So it's more governed by the SLAs and durability of the content in the S3 storage, but the files can still be accessed. Yeah, the mapping will not change. The application will still be able to look at the files in S3 infrequent access or reduced redundancy.
Yeah, but there will be less costing. Is it?
Cost of
In
storing
infrequent
is,
access.
yeah, cost of storing the data in infrequent access is definitely less. But if we start accessing it very frequently, right, the bills will just bounce up.
Yeah, that's.
Okay.
I think what I suggest is we can I mean, this is not needed right now, but I just got a thought in my mind that if the data is not accessed for 60 days, move it to infrequent S3, and if it is requested, move it back to S3 and let it keep on S3 for another 60 days, so the cost can be reduced. Don't let it sit there in infrequent S3.
Yeah. So if somebody has accessed it, yeah, it will have its timestamps changed, and based on that, it moves back to S3. Yeah.
So
Okay,
this is automatic, right? This is not something we'll be doing. I mean, at the timestamp change, and it will automatically move to S3.
No, it will
No,
not.
Amit, we have to write a rule that if the data is not accessed for 60 days, move it to infrequent S3. And if at the moment, as soon as it got its timestamp changes or someone tries to access it, move it back to S3. So for that also we have to write a rule. But once the rule is written, it would be automatic, though no manual intervention will be required. Right, Anand?
Yeah, absolutely. You need to have the life cycle policies or the life cycle rules written. See, Amazon is giving us various options, right? Various options. Now we choose those options depending on our need. Well, you may be saying, hey, I need it automatic. The other guy may saying, no, I will choose. So Amazon is not taking the decisions to do things automatically or manually. What Amazon is doing is giving you the options there and giving you a dashboard so you can punch in the numbers to when you want it to move to infrequent access, when you want it to take it back and put in S3 standard. So it is giving you a framework and not a rule book. So depending upon the decisions taken by your architecture team or by yourself, you can use those options available and leverage them. But again, yeah, we're talking about best practices here, and I agree with you there. Yeah.
And one more thing, if we keep the storage gateway as as a EC2 instance, then the data over the internet will not be encrypted, right? Or will it still provide some option to encrypt it over NFS or SMB?
Yeah, it will be encrypted. Even if you create a VM in EC2, it will be encrypted. There will be multiple layers of defense because where is it? Yeah, because your VM is inside a subnet that is inside a VPC, and that is connected to Internet Gateway. Look at the number of layers the traffic has to go through. There is one filter right here at the Internet Gateway, and that filter is called as routes. So unless you allow the traffic at this route level, it will not get in. Then you got some kind
No,
of
in terms of encryption, I meant as HTTPS protocol or like that, not security point of view.
Yeah, I agree with you. It is encrypted. True. It is.
It is or it is not if the gateway would be a EC2 instance.
It is.
Then over the it is.
Yep.
Okay. 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 No questions. Thank you.
Thank you, man.
So is the break started or you're going to start it?
I would like to study with you. I would like to take the breaks with you. So let's take the break together. So it's about 8:11. Let's come back in. We took a longer session. Is 15 minutes okay for you guys?
Fine.
15 minutes. Okay. So welcome back, everybody. Hope you got a good breather. Let's get started with the next subject here, which is architectures of cached volumes and stored volumes. We'll also have a demonstration where I'll show you how you create the file gateways. Starting with the cached volume architectures. Let's understand the cached volume architecture, and in this architectural demonstration, you'll see that Amazon S3 will act as a primary storage because we save entire data in S3 bucket, and the storage gateway will retain frequently accessed data, and this infrastructure or on-premise infrastructure will make sure that you minimize the need to scale your on-prem storage design. And it gives applications with low latency access to their frequently accessed data because we are caching frequently accessed data. Data is kept on-prem. And now you can have these storage volumes up to 32 terabytes as on today. And they have been created and attached and mounted as iSCSI devices. They are mounted as iSCSI devices. And they are mounted on your premise application servers. There's also the volume gateway, right? There are two components of the volume gateway, which is cached and storage, which is stored volumes. So the volume gateway that store the data that you can write to these volumes in S3 and retain those recently read data in your premise. So there's a cache buffer and an upload buffer. So there's a cache
buffer and upload buffer. I'll just repeat the same statement. You store the entire data into the volumes that are being backed up by the S3 bucket, and the frequently accessed data is being retained on premise within the storage gateway cache and in the upload buffer storage cache. There are two components of it, cache buffer and an upload buffer. There's a size to each of those components as well. Let's specify the sizes. The size of each wall.
How these
Sorry?
two buffers different with each other?
Yeah, we'll get there. The size of each
from each other. Okay.
The size of each volume can scale between 1 GB to 32 GB. Well, it's a 32 TB. So each volume gateway can support up to 32 volumes. So each volume gateway, and how many volumes can I have? 32 volumes. So in total, it means that maximum storage capacity, it can go up to 1024 terabytes or 1 petabyte. After the installation is done, after the activation of your storage gateway appliance is done, you will deploy storage gateway appliance on premise. So storage gateway appliance goes on-prem, it just goes on-prem. And like I said, these appliances can be on a virtual machine running on VMware ESX or Microsoft Hyper-V, or you can create a storage gateway appliance running on EC2 instance on AWS Cloud. So these storage volumes are being mounted as an iSCSI device on your premise application servers. So these storage volumes are being stored and they talk to your S3 buckets that can then be mounted as an iSCSI appliance to your premise servers. And these volumes will contain your entire data storage. The storage gateway will run in two different ways. Either you can have a VM on-premise or you can have an EC2 instance performing the same job. So the essence of a cached volume architecture is that the entire data stays in volumes being backed up by S3 and retain the frequently accessed data or the cached data within the storage gateway on premise, and that cached content will go into the cached buffer. It is called as a cache and a buffer because what is frequent today or frequent in 1 hour may not be frequent in the next hour or in few days. So the content of these buffers is ephemeral or temporary in nature. What needs to be uploaded back to the S3 or what is not being accessed frequently will then go into the upload buffer from the cached buffer. So if it thinks that certain content is sitting in the cached buffer or in the volumes on your premise, it will then sit in this staged area ready to be uploaded to your S3 from the upload buffer. So you're retaining the frequently accessed data or cached data within the storage gateway on-premise infrastructure. There are two different disks and two different data storage being supported by this architecture. We just spoke about one, which is cache storage. It acts as an on-premise durable storage. So let's make points here. Cache storage is an on-prem durable storage. And this is the data that may get uploaded to S3 via the upload buffer. The cached storage also lets the gateway store your application's recently accessed data for low latency access. If your application requests data, the storage gateway will first check the cache storage before checking the S3 bucket. And if any of your servers or applications need access to the data, that data will be first looked into the cache storage, and then later on the transactions are sent to the S3. We just spoke about upload buffer as well. So upload buffer is nothing but it's a virtual disk. Virtual disk that acts like a staging area for the gateway before the data is uploaded to S3. The main purpose of the upload buffer is that it acts as a staging area. It collects all the data and pushes that data into the volumes being backed up by S3. I'll quickly pull up a diagram, and that actually demonstrates the whole thing, just like what we did earlier. Okay. Oops. All right. So what's going on here? If you see in this diagram, you would see that on the left-hand side, right here, you got your data center, and on the right-hand side, you have your your AWS cloud infrastructure. In your premise data center, we have these application servers right here, and these are the storage appliance gateways. Now this storage gateway consists of two virtual disks. One is a cache storage that will contain the entire cache or the frequently accessed data. And there's another one which is the upload buffer. And the upload buffer will just collect all the data and push that data to the volumes being backed up by S3. Goes right there in the form of snapshots. Now if you look at this, look into the AWS storage infrastructure. These are the volumes being backed up by S3. So you put all your data into these volumes. And the cache storage that's part of the storage gateway will retain the frequently accessed data. These volumes that are being backed up, any volumes that are attached to the application server, can then be backed up by S3. They can then also be mounted as an iSCSI interface devices to your servers. So whenever your server on-premise writes some data, that data has been pushed to your storage gateway. The upload buffer will just collect all the data and push that data and store that into the volumes in AWS. The cache storage will just have the frequently accessed data. So these servers, whenever these servers want to retrieve any data, that data has been looked into the cache storage volumes before the data can be retrieved from any of the volumes in S3. And these are local disks that stay on premise. So you just have to carve out on cache storage and upload buffer from these virtual disks on premise. Apart from that, you can have the snapshots that act as a backup of these volumes that contain your entire data. So this is the architecture of a cached volume architecture. The next one is volume architecture. Now let's come down to the volume-based architecture. It is opposite to the cached architecture that we discussed earlier. And in this architecture, the primary data is stored on premise. So all your data is being stored in a local disk. All right, data is stored on your local disk. and on your premise. And the data is being asynchronously being backed up to S3 buckets. And this architecture will give you your on-premise applications with low latency access to the entire data sets, and it will give you durable off-site backups. So in this case, your apps and your servers both get low latency access to the entire data sets, and in the background, the data has been backed up to S3 buckets. Storage volumes are being created and mounted as iSCSI devices from app servers on your premise. Now these storage volumes are part of the storage gateway. The data is being written to your gateway stored volumes. So each and every bit of data that is being written is being stored on your premise. And this data is being asynchronously backed up to S3 in the form of snapshots. Each stored volume architecture can support volumes, and size of each volume can scale from, again, 1 gig to 16 terabytes. And then in total, you can have 32 volumes. And this means that you get a total volume storage that is supported as on today is 512 terabytes. Once you've configured and deployed your storage gateway in your data center, you can then use storage volumes and map them to on-premise direct attached storage or storage area network disk. Could be DAS, or it could be iSCSI enabled DAS or iSCSI enabled NAS. SAN. So what you do is that once you create and configure storage gateway in your data center, you have to carve out what part of the storage volume is a cache and what part of the storage volume is a buffer. So whenever the data is being written or read from the storage volumes, the data is stored and retrieved from the volumes assigned disk. So these storage volumes will help the servers in your data centers to read and write the data to the local disk in your data centers. And now you have the upload buffer, which is part of the storage gateway. And it, again, just like earlier, it gives you a staging area. We made this point earlier that upload buffer is a staging area from where the content is pushed or uploaded to S3. So over here, your upload buffer is nothing but a virtual disk where the data is temporary. And that's part of your storage gateway. That will be collecting all the data and uploads that to your AWS cloud infrastructure. And that data is kind of, you can say, it's kind of a backup snapshots being backed up by S3 buckets. And gateway uploads this buffer data over, it uses SSL connection to AWS and encrypted by server-side encryption in S3. So this entire data is being transported over an encrypted connection, snapshots, which are incremental backups. Of course, the nature of snapshots are incremental in nature. Always remember that. Snapshots are incremental. So snapshots, which are incremental backups, can be created on your storage volumes, and you can always restore a snapshot to your on-prem and then recover your data. Snapshots are being backed by S3 in AWS, and they are incremental backups. Any questions, team? So what we need to do is create a storage gateway first. For us to create a storage gateway, like I said, a file-based storage gateway can be on-premise or it could be on the cloud in AWS. And if you would like to create an EC2-based storage gateway, then it must be of minimum M4X large size. It must be minimum M4X large size. I've got this step-by-step documentation from somewhere, which I will be uploading to the drive again. I'm just trying to pull up. Yeah. All right. So what are we going to do in the lab? What we're going to do is, let's say this is an application server. Quickly make notes there. Is an app server, and then what you also create is storage gateway on-premise, and because we do not have an on-premise infrastructure, we'll create an EC2 based storage gateway. All right, and we'll see how we can connect it to an S3 bucket, right? And it's important to have the network communications established. So we may have to point it out like that and put some arrows as well, because the data is written. Yeah, you write the data like that, and for us to write the data you need an IAM role, because if the storage gateway needs to write something to S3 bucket, it needs to have permissions. And once everything is configured, what you will eventually have is an NFS mount point, which we'll see how we can mount it to Windows machines or Linux machines. So what do you need? You need to create, or let's say you choose a storage gateway. I'm going to make those labs step by step. Number one, you choose a storage gateway, and we know that there are three kinds of storage gateway, and we'll experiment with file gateway. And then once we select the file gateway, it will say, hey, what kind of gateway is it? Is it on-prem or is it EC2 instance? And because we do not have an EC2 instance, we gotta create one. We have to create an EC2 instance of what size? M4X large minimum. That's as per the documentation. So that's the instance type, right? What else do we need? We need volumes. Volumes for the gateway, we'll select like 80 GB. That's minimum requirements. And we'll also have a cache disk. So this instance will have two disks, 80 gigs and 150 gigs for the cache. That's a minimum requirement for this, as outlined by Amazon documentation. So once this is completed, you will have the gateway created. You then have to pick up the public IP of the EC2 instance and point it to the storage gateway. You're telling that my storage gateway is that EC2 instance by pointing the public IP to it. Then finally you activate the gateway, and then you configure the local disk, or let's say you create a file share by mapping an S3 bucket to it. Then you can use this file share to mount to any instance, Linux, Windows, or Mac. We need to make sure that the EC2 instance is listening on the following ports: 111, 20048, 20049, port number 80, and port number 22. These are the ports that it will need to communicate from storage gateway all the way from S3 bucket. So I'll go back to my AWS console and start doing this step by step. I'll go to my storage gateway and wait for this to open. And then say get started. Always make sure that you spend some time reading this and then what's in there, because things change. They may have a fourth one here, but things keep on changing. So please spend some time reading what it is showing. As discussed, we got three kinds of gateways: a file gateway, a volume gateway, and a tape gateway. I'm selecting file gateway. It will store files as objects in S3 bucket with the local cache, etc., etc. Like I said, always give it a read. So next, the platform that I'm interested in is not ESX or Hyper-V. I want to create an EC2 instance, and I haven't created an EC2 instance yet, and I'll make my life easier by clicking on launch instance. And it automatically picks up an image. It automatically picks up an image from there. And I gotta scroll down and make sure that I select an M4 X large instance. And keep in mind that this is not free. The only thing that's free is T2 micro. Even in free tier, if you just created your account yesterday, that it's in free tier. No, M4 X large is not in free tier. The only one that we get free is T2 micro. So if you're doing the lab in your accounts, yeah, you might be getting bill. And if you're doing the lab in my account, of course, I'll be getting the bill. So this is giving me like 4 CPUs and 16 gigs of memory, which is okay. Instance details. Ah, what's going on? There's no VPCs here in Ohio. Huh. So I will quickly change this to North Virginia and cancel this. Probably go to North Virginia right from here quickly. Please bear with me. No problem. All right, file gateway, next. I just changed the region to North Virginia because my Ohio region does not have a default VPC, which is okay. Launch instance. Scroll down and then select M4 X large. Keep moving. There is a VPC, couple of VPCs out there. It doesn't matter. I'll go for the default one, and subnet doesn't matter. Make sure that it is enabled so I can PuTTY or SSH to this machine later on. Storage, like I said, as per the documentation, we need 2 volumes, 80 gigs and 150 gigs. So I will, all right, it gives me 80 gigs by default, so I'll add another volume. EBS is good, but gotta make this 150 gigs, okay? Yeah, fair enough. Click next, add, and I'll add a tag to this. Doesn't matter what name you give, but give it a proper name: storage underscore gateway. Okay. In the security group section, I gotta have all of those ports open, so I will spend a minute doing that. Yeah. 111. Add rule, custom TCP 111. From where? I'll just do it from anywhere. It's not recommended that you do it from anywhere. You'll just do it from the device from where you want to mount it, right? Add rule, and then, oh, did I say 20049? No, it is 2049. And the next one is 20048 and 2049 and HTTP. All right, 1 2 3 4 5. 1 2 3 4 5. Okay, and let's quickly do that. Super cool. Say review and launch. Everything looks good. Click on launch, and I will create a new key pair. Give it a name, storage exercise, whatever, storage. Yeah, STO. Okay, doesn't matter. We'll wait for this, save it, and launch instance. All right. So now we have to wait for this to complete fully. All right. What we have to do here is click next, and then what it asks you is the public IP address, the public representation of your storage gateway. It says type the IP address of your gateway. Your web browser must be able to connect to this IP address. The IP address does not need to be accessible from outside your network, right? So what I did when I was configuring the inbound rules is, although I've given the ports properly, I said allow it from anywhere, which is not a right configuration. You should allow it from specific IP address, which is okay in this test lab. I'm fine, but in production environment, do not put 0000 because everybody can then access it. And the IP address of the storage gateway that I gotta put here is this. So I'll copy that and paste it like that and say connect to the gateway. It may not be accessible right away. Yeah, it says 404 not found because my VM is still initializing. So I gotta have a patience pill and wait for that to be up and running. And then do this. And if it still does not connect, then there's something wrong with the security groups. All right. Just waiting for this 2x2 checks to complete. Usually these are pretty quick. Amazon instances, Amazon Linux instances are pretty quick, but Windows takes time. Any questions so far while we're waiting for that to complete? Vijay, I see that you got a raised hand. I see that in the chat box. Do you have a question, please?
No, I'm sorry. It was just clear.
No problem. That's okay. Thank you. That's okay. In the meantime, I'm still creating the instance. Okay, so I'll go ahead and create an S3 bucket now because I'll need it anyways later on because I need some kind of a mount point later, and I'll give name like file storage gateway, and of course I think you know that this name must be unique, right? Nobody else in the world must have used this name. So when I click next, all right, and then just leave all of that as default. Awesome, that was very fast. EC2 is still sleeping, it's taking its time, but I can still play with this. There you go, something
Hi
happened.
Anand, this is Sat.
Hey, hi.
I have one. This file gateway, the storage gateway, can we use it for some other purpose as well, along with gateway purpose? I mean, can we install anything on the server and access it over the public IP address?
Yes, you can. So Amazon is not stopping you to use this storage gateway for other purposes. You can absolutely do that. But they also say that they're not recommending to put anything else because it's already pretty busy, doing a lot of or handling a lot of workloads of your on-premise, doing encryption thing, handling the data back and forth, a lot of transactions happening between the disks. So the IOPS of the disk are already utilized for what it is supposed to do. So if we use it for any other purpose, then you are putting an additional overhead on the storage gateway. When things go wrong, it will be very difficult to troubleshoot and narrow down on the actual root cause.
Okay.
So it went through, as you noticed that, it just went through after typing in the IP address. It went through, so I'm selecting a proper time zone because this is where my gateway is, right? North Virginia, and that's in East Coast, so I selected that and say activate gateway. We again have to wait for some time for the local disks to populate, and we just have to wait. I've seen that even this fails, and we have to do this like another time to get the local disks prepared properly. So fingers crossed. I'll just pray the demo gods for a while. All right, something happened right there. It detected one of the disks, and you can allocate it to a cache or just unallocate it. You don't want to do that because you want to do the labs. So I'll say cache and say save it. That's done. So a lot of steps have been completed. So I'll go back to this document where we wrote the steps. So we chose a storage gateway, file gateway, and our gateway is pretty big, M4X large, which is 16 gigs of memory. Added 2 volumes and 150 gigs for the cache. And after the VM was provisioned, I got a public IP, which I then mapped it to the storage gateway. We activated it. We were patient all that while, and finally we got the gateway created as well. Now we are in the step number 6, where we would like to map the file share and map it to the S3 bucket. All right, so I'll go back and say create a file share and put in an existing S3 bucket. I don't remember the S3 bucket name, so I'll go back here. It looks like that's the name. And like I said yesterday, I'm a lazy admin, so I'll try to see if I can copy and paste it there. And you got 2 options. Do you want to use an NFS or SMB? NFS and SMB, there's a difference because SMB will let you integrate with Active Directory. Let's see there, and then in fact let's go through them one by one. I've selected SMB at this time. I click on next. Do you want all the objects to go into S3 standard, infrequent access, or infrequent access single zone? You got these options as well, which is great. And it will automatically create an IAM role so that the storage gateway can upload the content to the S3 bucket, and it needs permissions. The permissions are granted right there. I click next, and if you look at this, it needs SMB Active Directory permissions, and it will fail. So SMB by default it is integrating with Active Directory, and in my subscription I haven't created any directory services. And if you remember, we were discussing about this a minute ago. I think someone asked the question about propagating permissions from on-premise to the cloud, and that's clearly possible if you have integrated your on-prem Active Directory to directory services in AWS. And since we don't have it, I'll go back and select NFS this time because it does not need Active Directory. All it needs is a mount point, right? S3 standard. Hit next, and this will accept any NFS clients because allowed clients are 0000. Okay, which is not good. Because I allowed it on the security group. So of course in production you will not do this, right? You'll have a specific IP address there. Okay, that's review. All that is good, and say create file share. Again, let's be patient for this to create. It takes a few minutes to get that done. It is still creating, but I clicked on it because I was curious to know what is the metadata of this file share. If I scroll down, it tells me that that's the gateway, that's the S3 bucket is connected to, and I am uploading to S3 standard. It can be used as a read-write storage, allowed clients for everybody, which is awesome. Given full permissions, right? And how do you mount it on Linux? Like that. How do you mount it on Windows? Like that. And how do you mount it on Mac OS? Well, like that. So all you got to do is copy and paste those commands on Windows and Linux platforms appropriately. Now I cannot move NA forward from there because this mount command does not work on my machine because I'm using a home edition, right? MS Info 32. I'm using a home edition of Windows 10 OS, so I cannot move any forward. Mount will work on enterprise and professional or ultimate versions of Windows 10 where I can have an NFS client for Windows. But there was one question. If a question was if I can mount this thing, a storage gateway, on a Linux-based platform. So I'll quickly go ahead and create a Linux instance in North Virginia. I'll not use the same thing, but this should be pretty quick because that's still being provisioned, going the same default enable, okay. Add storage, I don't care. Tags, security groups, I-122, perfect. Review and launch, and I want to use my key because I have it. All right, so while that is being provisioned, I'll quickly use puttygen to convert the PEM file to a PPK. Say load. I think the file name was, what was the file name? Storage. I know, all files. Store something. Oh, it's in downloads. Store, yeah, sto.pem. Okay, save it as a private key and go to my desktop and say store. Doesn't matter what name it is, but yeah, fair enough. Use putty to SSH to this new instance, and SSH there, auth browse to my file on desktop, which I call it as store.ppk, and open. Although it is still initializing, but it will connect. The username is ec2-user. This is great. So let's see if we can mount it. Is this guy ready? Is this guy even ready? It is still creating. So wait and watch. Oh wow, it's available. So I'll just go ahead and copy that. Mount path. What do we put the mount path as? /dev or something? /etc/ maybe slash what is Gantt? Where am I located? There. So sudo mkdir alpha, got that, ls, I got alpha there. So I will mount it on /home user, that path /alpha, /home user /alpha. Okay. Okay. Let's see. I'm not able to copy, which is nicht gut. Here you go. If I do df, do you see that? The storage gateway. I'm able to mount it and it's visible on my disk. It's probably visible on my disk. Right? So definitely I can use tools to now connect to it and copy the content to it. That will definitely go to the S3 bucket in a while. Is this concept clear? Any questions? I think I have demonstrated this end to end.
I have one question. Earlier you said that the storage gateway should be available on premises on the client end. But here we created one gateway on our AWS side, and we mounted the file system over the internet.
Yeah. It's always recommended that you keep it on premise, because most of the whole purpose of storage gateway is to create a hybrid connectivity from on premise to the cloud. But like I said, if there's a startup or company, it's a new company, and in that case, they will not have anything on their premise. And if they still want a private communication, then they have no option but to create a storage gateway in AWS. So AWS is giving us various options, but there's a recommendation, there's a suggestion that if you have on-premise infrastructure, then you create a virtual machine in VMware or ESX on your premise in your office, and do not use an EC2 instance. But let's say I'm a startup, I got nothing on my premise. I'm working just with my laptop. Then I need to have something to copy from my laptop all the way to the S3 bucket privately, securely.
Okay. Now, two questions. One, if I do this the same way, if I mount the file system over the internet using SMB or NFS, is it secure? I don't think SMB is secure over the internet.
That's why we are using SMB version 2 and above, and we do not use SMB version 2 these days. 1 is gone. There were a lot of vulnerabilities that were found in 1. 2 is almost gone. So today with Windows 2016 and 19 onwards, people are using SMB version 3.
Okay, and if we create the storage gateway, what version it will install by default?
It depends on what version you're using. So the protocol negotiation happens at the TCP level. So if I'm using an older version of operating system, I'm not using Windows 10, but if I'm using Windows 7, then it will be compatible with SMB2 only. But our storage gateway works with both SMB3 and 2. So it's just a TCP three-way handshake, and the protocol negotiation happens at the TCP layer of the OSI. If my Windows operating system is compatible with 3, it will use 3.
Okay. My next question is, maybe it is a very basic question, but I want to clarify. If I create one EC2 instance and I share one SMB share on that EC2 instance, I create a share folder, I do it under Samba services, and I mount the same folder which was shared earlier over the internet to any client, say Windows 10 or any other client. Is that the same thing as we are doing it in storage gateway, or it is a different thing?
It's a different thing, because storage gateway is not used to store the content. Storage gateway is used to move it way back to S3, where you can manage your files better, write lifecycle policies, and cut down your costs. If we ever have to copy the content from on-premise to an EC2 instance, you do not need a storage gateway. The whole purpose is to move it to S3, use lifecycle policies, retention policies, create geo-replication policies, which is much cheaper than using an EC2 instance. If you're using EC2 instance just for storing purposes, then that's not the right design. For storing purposes, you got storage. If ever you need computing, like CPU, memory, that's when you will need an EC2 instance. Just for storing, I do not need an EC2 instance.
Okay, and if I mount one S3 bucket on EC2 instance, and I share any folder from that mount point, so I think that will be the same as storage gateway.
That is a storage gateway, yes, because directly you cannot mount an S3 volume. In S3, you have no option to mount it as a volume on an instance. It has to go through a storage gateway if you ever have to mount it as a volume. Or there are third-party tools.
Okay, so S3 bucket cannot be mounted directly on EC2 instance.
It cannot be.
Okay, that's good. Thank you.
Welcome. Thank you.
this storage gateway will always be a Linux machine, or that can be
Yes.
a Windows as well.
It's actually an image. It's actually an image that Amazon gives. It's a special image that Amazon gives us, because it has a lot of things. It has the application installed, software installed that makes it a storage gateway. It cannot be just any other EC2 instance, or it cannot be just any other Windows instance. It has to be done through the method that we saw. For example, doing like this. So when I click on EC2 instance, launch instance, it will pick up our special image, the AMI of which is this. So even if I Google for this, right, Control C and Control V, it will take me to the storage gateway documentation. So it's a special image. See, the same steps.
Okay.
Okay. Yes, there's a question from Debasis. Oh, Neftali. Yeah, so all these sessions are recorded, and I've uploaded it to the drive. I think Paul shared the drive link, and I'm going to copy and paste that again in the chat. So it's right there, and you will find the video and the notes that I'm making during the session there. So with that, we conclude. I think I'll just close that. With that, we conclude the storage gateway part of it, where we learned about how you can create a hybrid connectivity and what are the options available in AWS Storage Gateway to connect to your on-premise to S3. Okay. Let's go ahead and talk about NAT gateways in AWS. So with your permission, should I go ahead, or if you have any questions, please let me know. Okay, guys. So we'll continue with NAT gateway in AWS. We understood what S3 is. S3 is an object storage. Glacier is used for archival purposes only. And it's always recommended that you do not access the information frequently, and that's stored in Glacier. So because your bills will just go up, that's not the purpose of Glacier. Glacier is for long time retention. And if you have such policies, if you need to comply to compliances like PCI DSS, where you got to keep the data for at least 7 years, forensics and investigation, government, where they have to keep the biometrics, facial recognition, and citizens' credentials, of social welfare information in the database for a long time. At the same time, they don't want to pay or maybe just increase the cost for no reason. Then Glacier is the way to go, because you can keep the data for a long time with less cost in Glacier. But if the data is being accessed very frequently, you'll go for standard class of S3. If the database is being, if the data in S3 or the object data in S3 being accessed infrequently, so you Just put infrequent access storage class, and there's another one called as reduced redundancy storage, also called as RRS, where Amazon does not guarantee that the data the data will be redundant. So the SLAs and the durability of the data will be far less in RRS. Recently, Amazon came up with another one, which is infrequent access single zone, 1AZ, which means that your data will be kept only in one single availability zone. In other cases, like standard storage class and infrequent access, you will have 3 copies in each AZ, right? But if you do not want that, you can have the data in just one AZ by choosing infrequent access 1 AZ, a single AZ. Moving on to NAT gateways in AWS, we'll come back to jump host and bastion host because this section is part of it. We'll come back to that one. Are you guys tired? There's no sound from the other side. Are you guys okay? Should we move on?
Yep.
Okay. These virtual sessions are at times difficult because I do not see the participants' expressions. I don't know what's going on the other side. If it's a classroom session, I can always tap on your back and say, hey, did you do the labs? How's it going? Are you understanding? But here I don't see that. That's one disadvantage of the virtual sessions. But of course, there are a lot of advantages though, from a trainer side and also from the participant side. It just kills that personal touch. Going back to the old school method is always great. But anyways, so as long as you're active, it just motivates me. So moving on to the NAT gateway section. Okay, NAT, the term NAT. This is an acronym and hence it must be in uppercase, right? An abbreviation that stands for Network Address Translation, right? Now, the instances that we created here, where are they? Right here. They are public-facing instances, right? They are instances that are exposed to the public network. They got public IP addresses. That means you can directly RDP to them or SSH to them. In certain cases, what I will do is open a notepad and start making notes and give it a headline as well. NAT gateways. Awesome. Okay. NAT gateways. So in certain cases, you may have to keep your instances private. That means they will not have a public IP. And if they do not have a public IP, then they won't have access to internet. And that also means that they cannot be patched. They cannot have the signatures of their antivirus, let's say AV, updated, right? And that's bad. If you look at the machines or your laptops at your home, there is a NAT going on. Your laptops, mobile phones, iPads, PDAs, they do not have an IP address, or rather, they do not have a public IP address. The device. Sorry.
So you mentioned that if they don't public IP, they don't have access to internet. But if you attach them to internet gateway, they will have, and still they don't have the public IP.
If you attach a virtual machine to an internet gateway, they will have internet. Is that what you're saying?
Yes.
And how do we do that?
No, I'm asking you, if you attach it to an internet gateway, will they have public IP or they can access the internet from there?
You cannot attach an internet gateway to an instance. You can attach an...
No, a VPC. I'm into VPC. Yeah, VPC.
Yeah. You can attach an internet gateway to a VPC and they will still not have internet. The only way to give internet is by giving it a public IP. Okay. Sir, is that clear?
I have some doubts, so I'll check on that.
Internet gateway is a must for a VPC. And even if the internet gateway is attached to the VPC, the EC2 instance that does not have a public IP, it will not have an internet. It will have internet only if it has a public IP or an elastic IP. That's the only way to do it. Otherwise, you'll go for a NAT gateway. NAT gateways will give you internet.
That elastic IP will be internal, right?
Elastic IPs, when you say internal, what is it? A private IP?
The static IP, or is it?
Yeah, you're right. You're right. Elastic IPs are nothing but static public IPs. Whereas if someone ever says public IP, it just means that the IP may change. It's a dynamic public IP. But regardless, it needs a public IP of some sort, either static or dynamic, for the virtual machine to have internet.
Okay. Thank you.
Okay. I mean, you'll actually see it in the lab when we do it. You'll see that. Okay. So yeah. So these poor virtual machines that are sitting in your VPCs, according to the compliance rules of PCI DSS or HIPAA or FISMA or FedRAMP, and the list is endless. There's so many of these compliances worldwide. PCI DSS for payment card industry standards, HIPAA for Health Insurance Portability and Accountability Act, FISMA for Federal Information Security and Management Act, FedRAMP for Federal Risk Assessment Management Program, and this list can just go endless. So if we ever have to comply to them, they say that your PII, which is personally identifiable information, must not be exposed to the internet. Let's understand that by drawing a diagram here. We'll go back to day one, which was yesterday. We'll quickly draw that VPC with two subnets, subnet 1, subnet 2, and we did draw an internet gateway, something like that, and the traffic comes all the way from the internet to, well, let's draw an instance first. That is an EC2 instance, right, which is a web server. So traffic comes like that. Let's choose a nice color. All right, so traffic does not go like that, but it goes via the internet gateway, so from outside. Okay, it goes from outside. I got the rules here, or the routes written here. It lets you in. I got the knuckles at this level. It lets you in, and then finally I got the security groups. So let's say your web application is hosted there, and then you do http://timesheet, not timesheet, but an e-commerce application called, let's say I'm selling racks, e-commerce application called racks.com. How do I reduce the font? Okay, not bad. Racks.com. People access the racks.com like that, and there's people need to fill up the information, so I have kept my database somewhere here. That's my database, and any transactions that happen to the database, you know that it must happen through the web server and not directly. Now, what's the point of exposing this virtual machine or database to the internet when the transactions are happening internally? So this machine will be nothing but, oops, what did I do? Private, I don't like the color. Yeah, private. This will be a private instance, and I'm calling it as a private instance because it has a private IP only, strictly. because I need to follow these guys, compliance guys. Whereas this machine, which is a web server, it will have a public IP because people are accessing it from the internet, and hence it must be exposed to the internet over a public IP. Static or dynamic doesn't matter. Now the question is, how will you update these virtual machines that are there in this subnet and they have just private IPs? And that's where I bring in a NAT gateway. I bring in another device called as a NAT gateway, and I will use a special picture for it. Okay, how about a hexagon? Is this a pentagon? Okay, I'll use pentagon. So this is how about a different color? Okay, so this is NAT gateway, and I'm putting that in a special subnet, which is a public subnet, and I will assign I got lack of inventory here. Maybe, yeah, how about this? Okay, I will assign this subnet. I will assign this subnet to my NAT gateway, something like that. So my private subnet, I'm calling it as a private subnet because all the instances that are there in the private subnet have the private IP, and hence I'm just giving it a hypothetical name called as private subnet. I'm assigning this private subnet to the NAT gateway, and I will give a public IP, probably an elastic IP to this. I will assign an elastic IP to the NAT gateway. So whenever these guys need internet, they will go out of this subnet and talk to the NAT gateway. The NAT gateway has an elastic IP and will go out from the internet gateway to the internet. If you do not have a NAT gateway, these guys who are sitting in the private subnet will never find a route to the internet. Okay? Is it clear? We will do this in the lab. I'll show the demonstration as well. Okay, now I'm just getting to this concept of jump host and a bastion host before I start the demo of NAT gateway. The question is, the challenge here is, you got a data center somewhere here. You got a data center right there, and you are sitting inside this network, right? You are sitting here. That's you and me, right? Both of us are sitting right there, and you and me need to, who are administrators, need to patch these virtual machines, needs to update. So for n different reasons, I need to RDP or SSH to it. How do I do that? Then this machine has a private IP. We found a solution for a specific problem, and the problem was that these machines do not have internet. So now you can, or these machines can talk to the internet for various purposes. But how do you get into this machine, right? How do you get into this machine? This machine does not have a public IP. Unlike this machine, we just were able to get into it easily because it had a public IP address. But these machines do not have a public IP. How do we get in? Well, what you do is create a special subnet. And in production environments, we call it as bastion subnet or a jump subnet, and create one virtual machine probably Windows or Linux, doesn't matter, one virtual machine which will have a public IP. Okay, and because it has a public IP, you can definitely RDP from your premise or from your home to this machine, and from here, now you're in a LAN, you're in a common LAN right now. You can definitely talk to this guy from this machine over a private IP, isn't it? So from here to here, the transactions will be on a public network, and this transaction is happening on a private network. Is it clear? Guys, questions please.
Yeah, do we have a way to access the private subnet from the outside world by using the NAT gateway?
No. So let's use this analogy. At your home, you got a laptop, and you access the internet through the router. So you can access the internet through the router, but nobody from external world can access your laptop with the help of an IP address. Even if they know the IP address of the router, they cannot get into your laptop or your mobile phone or your iPad. That is nothing but a NAT. The NAT is happening right there at your home level. And we're just expanding it to the corporate world or in AWS. So even at your home, if you are talking to the internet doing google.com, it is a NAT. You are behind a NAT, and your router is handling all those network address translations. And network address translations are one way. It doesn't happen from the internet to your machine. It happens only from your machine to the internet. Right?
Yeah, sure. Okay, thank you.
Let's go ahead and build this environment quickly. Okay. So I will.
In another way, this junk subnet and web server are doing the same thing. I mean, both have public IP and they allow internal communications.
Jump server. Yeah, so by creating a jump server, you're allowing an internal communication, provided you have ports open on the security groups, right?
Yeah, a web server will mean the same. So what ports are open, it depends on that. What makes you can make the same server a jump server as well by opening the ports.
Yeah. So a few things. I will go ahead and start from scratch. Create VPC. 2. Create subnet. I'll create 2 subnets, and one subnet will be public subnet and second will be private subnet. So by doing this, I can also show you how do you create a public and a private subnet. Next, third, create. I'm sure you got these steps on your tip of your tongue right now. What's the third step? Create internet gateway, and fourth, you attach it and then edit the routes to allow what? 0.0.0.0//0. Okay. Next, I will create. Oops, it's step 5. Create EC2 instance. Okay, I will create 2 EC2 instances. Whoop, what's going on? I'll create 2 EC2 instances. One will be private in private subnet, and second will be public in the jump subnet, right? Once they are.
4th point will be added the security groups, added the routes.
Sorry?
The 4th will be added the. I mean, 4th point will be added the security groups.
You will edit the security groups only after EC2 instances is created, because till the point EC2 instances are created, you won't know which security group is mapped to the EC2 instance. So you will edit the security groups to allow inbound connections from public instance to private instance, right? Because if you look at the picture, I am connecting from public instance to the private instance, so it must be inbound here. The traffic is going outbound from the public instance to the inbound of the private instance, and we never care about the outbound security groups or outbound rules, because it's always allowed. All the rules, all the ports are allowed. And inbound rules are more restrictive. So I'll allow inbound connections from public instance to the private instance. And yeah, then steps for NAT gateway. Go ahead and create a NAT gateway in the VPC console. You will need an elastic IP. So you attach an elastic IP to the NAT gateway. And this NAT gateway will be created in public subnet, which is my jump subnet / public. All right. 9. Then you associate the private. Look at this, what I did here. This blue line, I associated this entire private subnet and attached it to my NAT gateway. Associate the private subnet to NAT gateway. Then you also write a route to allow internet on the NAT gateway. Okay. I'll go ahead and do this quickly and show that to you. So I'll pick up Ohio region so that we start from blank slate, because earlier we got a message that there is nothing in Ohio. There is no instances, there is no VPCs. So I'll quickly go and create a VPC there. Okay, so my VPC is, okay, it's US East 2, it's almost there. Then I will click on your VPCs and create VPC. Give it a name. I'll give it a funny name today, create_labs or whatever. And the CIDR block is at 10.20.0.0/16. Okay, fair enough. And create. I'm not going to explain those things because we did that yesterday as well. Go to the subnet section, create subnet. I'll say private_subnet, and the VPC is this. Availability zone, let's put them in different AZs. 10.20.30.0/24. We learned about the CIDR block concept yesterday, so that's created. According to our documentation, I need to have 2 subnets, so I'll say jump_subnet, and this guy goes in the same VPC, and it will have a CIDR block of 10.20.40/24. Put them in 2C. I'm going fast because we did this yesterday, and most of us are already been through the essentials class. This must be pretty basic. All right, so I'm going to internet gateways and create internet gateway. I say IG_ whatever, IG_ home network, or IG_ home. All right, and then finally I attach it to my VPC, and that's the only VPC I got. Attach. Amazing. So I'm done. I go to the route table. I will have one route table, and I do nothing here but to edit my route, add route from 0.00 to my gateway so that the devices get internet. With that, I'm done with 1, 2, 3, and 4. Now it's time to create EC2 instances. One in public subnet, another in private subnet. But I missed a small thing. There is no difference between the first subnet and the second subnet. They have been created identically. But how do we differentiate? How do you actually make it technically private and technically public? So if I right click and say, where is that? Now read this. On one of the subnets, I right clicked and said modify auto assign IP settings. When you click on it, it says enable the auto assign IP address setting to automatically request a public IPv4 for an instance. So any instance that is launched in this subnet will get a public IP if this is checked by default. Although during the VM creation or the provisioning process, you do have the options to change it again, but this is the default behavior. So jump subnet has assign, I'll refresh it. Okay. Oh, okay. I'm looking at IPv6. I want IPv4. Wait a minute. Where is it? Yeah, right here. Okay, so jump subnet, any instance that is created in the jump subnet will get a public IP because it is set to yes. But any instance that is created in the private subnet by default will not get a public IP because we have that setting on and off, right? It's time to create an EC2 instance. So go to services, EC2, US is 2. Okay, good. I hope you're following me. I don't want to rush because of any reason, and if you are lost or something, please put it in the chat or unmute and ask the question. Okay, so all right, so let's go ahead and create instances, one in private subnet and another in public subnet. Launch instance, and I can stick to Linux, no problem, or Windows. Windows takes time, so that's why I do not choose Windows. And Linux is pretty quick, that's why I always like Linux. Otherwise, in your demos, when you're playing around, we can choose Linux or Windows, doesn't matter. Yeah, it really doesn't matter. The steps always remain the same. So yeah, T2 micro is fair enough, and I've got to spend some time here. Number of instances 1, put that in this VPC, and I want to create a VM in a public subnet. An automatic assignment of public IP address is set to enable, which is great, and that's what I want. Yeah, next storage, I don't care. Tags, let's give it a good name. This is my jump server. Next, security group, yeah, 22. Review and launch it, and really I don't have any key pairs. That's bad. SG123, okay, doesn't matter. In the lab it doesn't matter. In production we follow the naming standards. Okay, that's downloaded. Launch instances, and while this is busy preparing itself, going through step 1 and step 2, doing the status checks, I will quickly launch a second instance in a private subnet this time. Yeah, it goes into private subnet, and do not want to give it a public IP at all, right? Because we want to go through the NAT gateway setup. Okay, so we are doing 2 labs here. If you know, we're doing 2 labs. One is a NAT gateway lab, and second is a jump host lab. You're doing 2 things, right? So 1 bullet and 2 pigeons, 2 birds going off. So doing 2 labs. One is a NAT gateway lab, and second one is a jump subnet lab. So all right, this guy does not get a public IP. Click on next. Storage, doesn't matter. Add tag, and the name is a private, or maybe mission critical server, because I don't want to give it a private IP. So yeah, that's fine. Launch it, and I will use the same key. Launch instances. Okay, so I think both of them are busy preparing themselves, and while that is getting the ground ready for us, I will use PuttyGen. I will use PuttyGen to convert the PEM file to a PPK. So it must be somewhere sitting in my downloads. So J123, yeah, PEM file. Okay, save the private key. Doesn't matter. On your desktop, was that SG123 PPK. Good. I don't need this PuttyGen anymore. Launch Putty. Now I need to connect to my jump server, not to the mission critical server, because if you look at this metadata, the jump server has a public IP, but the private machine, which is my mission critical server that has a lot of PII data, it does not have a public IP, right? So we are checking how you can connect from this machine to manage it, right? So I will first connect to the public machine and point it to my SG123 sitting on my desktop. Okay, SG123, there. Open. And if I'm lucky, I'll connect. Looks like I'm lucky. So EC2-user. Super. Now I need to connect from this machine to this machine, this mission critical server, right? This guy. And I need to get that file somewhere, because if I say right click and connect, it tells me the command to connect, that this is the command ssh-i, the PEM file. So I need to have the PEM file sitting locally on this machine. I do not have the PEM file at all. So you know what I mean? So if I just copy this thing and run it like that, are you sure you want to connect? Yes, permission is denied, number one. So even if I do sudo, let's say I'm doing sudo, yeah, connect, yeah, see that identity file. Okay, I got the message right here. The file is not accessible, so I need to have that PEM file sitting on my computer, on this instance, not on my machine, right? Not on my laptop. It must be inside this. So I will copy and paste that. Okay. Where's my downloads? I'll open up that file, or let's go this process notepad. Is there a PEM file somewhere? Yeah, right here. So drag. Okay, drag and drop this guy. Where is it? Open. So I've got this. I'll copy all of this. Control A, C, without missing anything. I will go back to my friend here, clear the screen so that way you can clear the clutter, and I'll open a VI editor and call it as just any file, sg123.pem. Oh yeah, okay. And then I will insert the whole thing. All right, I got that file here now, right here. And if you look at the step-by-step instruction, I gotta also give permissions. chmod is modifying the permissions of sg123, so you at least give read permissions to that guy, right? Sudo, yeah, beautiful. And then finally you run this command, right here, enter. Permission denied. Let's do a sudo. It got connected. Yeah, this is 165. So we got connected, and we did not have to modify any security groups, probably because they are in the same SG and it's allowing from anywhere. So that's how it got connected, and that's how we could just skip this step number 6. We just skip the step number 6 because we are allowing the security group from 0000. That's fair. Okay, no problem. So we jumped from 40.30 to 30.65. So that's the concept of a jump server. But if you look at this guy does not have an internet. So if I do curl http://yahoo.com, it's just thinking. It doesn't give anything. It should have given me a banner. But on the other side, if I exit and go back to 40.30, run the same command, http://google.com, it gives me that. It gives me header, body, and all of the HTML content in google.com. But the guy does not connect to the internet. So that's where we need to have a NAT gateway created So that ways, this guy, when we do curl space http://google.com, it will connect to the internet if we have NAT gateways. It's not working. I will pause for a minute to take your questions and where you can address any confusions that you have. Just tell me and I will pause and answer them.
Now, I have a question. If we have to attach a public IP or elastic IP to NAT instance, then what is the use of a gateway being associated to a VPC? Why we need a gateway for a VPC?
Gateway is the first entry point. Gateway is the first entry point for the VPC. NAT gateway is only for the instances that are there in the private subnet or the machines that have private IP addresses only. Internet gateway is required for all the resources that you have in the VPC, regardless public or private. So if you remove the internet gateway from, if you remove the internet gateway from the VPC.
So you mean if
Okay, so if you go ahead and remove the internet gateway from the VPC, even the machines that have, or the instances or databases that have a public IP or an elastic IP, it will not work. They will not get the internet. So internet gateway.
So the gateway have some sort of routes defined, I think.
Exactly. In the internet gateway, we define the routes. Yes.
Okay. Thank you.
Yeah. So we just looked at the concept of the jump host, and this poor guy who is a private machine does not have access to the internet. What we're going to do is, see, it failed to connect to google.com. We'll go ahead and run this command again after creating the NAT gateway. Now we are moving on to the second lab here, where I will create a NAT gateway. Okay, click on NAT gateway, create NAT gateway. It is very simple. Just put that in the public subnet. Now my memory is not that great. I don't remember which one is a public subnet, but I can definitely look at these. When I know that my jump server is in a public subnet and my public subnet ends with 3095. So I'll go ahead and select 3095 here, and I do not have an elastic IP, so I'll say, hey, create a new elastic IP, and it did create a NAT gateway. Done. It is pending. Okay, so what did I do? I created a NAT gateway in the jump subnet or the public subnet and attached an elastic IP to the NAT gateway. Now I will go ahead and associate the private subnet to the NAT gateway. So what am I doing next is this. What am I doing is this part, taking the whole subnet and attaching it to this NAT gateway. So I'll go back here. Then where is my route? Oh, in fact, it must be done in the route table. So I have to first create a route table. Okay, give it a name, so nat_route. And then it goes into my VPC. Perfect. Okay, now this route must be associated to my private subnet, which is this, right? It must be associated to my private subnet. Saved it. Okay, so my new route. Okay, I think I messed this one up. It must be this one, not this. I must have done it here, but I did it here. So I will roll back changes immediately, like that. Okay, I'll go back to my NAT route and then edit associations. Private subnet is attached to my route. Done. And I also have to write a route so that it can access internet. And it will connect to my NAT gateway which is this. Now I will go back to my NAT gateways to see if it is available, and my whole setup is done. I attached an elastic IP to the NAT gateway, associated the private subnet to the NAT gateway, and then in fact this step goes first. Control X, Control V, and this is 9, 10. So we created a route to allow internet on the NAT gateway, and we say allow internet, it is 0.0.0.0/0. So you edited the route, and finally associated the private subnet to the gateway in subnet associations tab. Okay, and now I'm going to go back to this machine and run the same command. There you go. So if it's got internet right away, it's got internet. So this machine, which is running on 165, this machine is 165, 10.20.30.165, even though it does not have a public IP, has access to the internet. So are you clear with this setup? NAT gateways and jumpers.
Hey, I have one question. If we have created one private instance, say database server, and we have to patch that server from my satellite server, and that satellite server maybe there in my on premises. So to do that, we have to allow internet, and to allow internet, there is only way to provide the NAT gateway to that network. Is there any other way instead of providing NAT gateway?
So are you saying that you want to patch it from your on-premise from here? For example, you may have an SCCM server sitting here, right? You want to patch it from there. Yeah. It's a very interesting question, and that brings us to another topic of direct connects and VPNs. So if you want to have a private communication between your on-premise and the cloud, like that, a private setup, you will have a VPN. So you will do a VPN from your on-premise, from here to the cloud. And when you are in a VPN, you're in a LAN, right? This you're just creating a LAN setup. You can either use VPNs or direct connect.
What is this direct connect? Is this some kind of feature provided by Amazon or any other utility?
Direct connect is a service offering from Amazon that will let you establish a dedicated network over high speed from your on-premise to AWS. So using direct connect, you are establishing a private connectivity from AWS to your data center or to your office or to any other environment. If you want a lot of bandwidth, when I say a lot, it is up to 10 Gbps. So direct connect is supporting up to 10 Gbps of network bandwidth, whereas VPNs do not support so much of bandwidth. So depending on the kind of bandwidth you're looking between your on-premise and cloud or AWS, you may choose VPN or direct connect. So it's a dedicated.
Is direct connect chargeable to us?
Yes. Both VPNs and direct connect, both are chargeable.
Okay, so if I want to create VPN my own, say I want to create VPN directly on the private instance, or maybe we can do this like this. We create one open VPN server or client on Jump server, having the private having the public IP address.
Perfect, yeah.
To the satellite server which exists on my premises.
Yeah.
So in that way, we do not have to pay for VPN, and we can get the connectivity directly to my server.
Absolutely, absolutely. That is a perfect solution for a small and medium business company that do not want to pay for the VPN gateways. It's a perfect solution. But organizations actually use Cisco gateways or Juniper or Palo Alto gateways, and they pay considerable amount of money to those vendors. But yeah, I will absolutely buy your solution of using an open SSL or open VPN connection. If I'm using a small and medium business network up to like 200, 300 devices, that's fair. Yeah, it's good. Yes, it's a very viable solution.
Okay.
Yeah. Any other questions, team?
We have, for example, we have a private instance, and we connected it to NAT gateway, so it is having internet now. It can browse anything, it can download anything from the internet. So what is the difference? If we have allowed, if we have opened this server on the internet, then is it a private instance or is it not?
Yeah, the difference between a public and private instance is that you can access the virtual machine, which has a public IP from the internet. But the private instance is not accessible from the internet, even if it is connected through the NAT gateway. So the internet is not bidirectional. It's just like your laptop. Your laptop is behind a NAT in your home or at your home. You can access internet, just like the virtual machine or the instance can access internet, but nobody can access your laptop. Although your so can you RDP from a cyber cafe to your laptop at your home via the public IP of your router? Not by default.
By default, not.
Yeah.
But if we create one NAT rule, then we can.
Yeah.
Now, again, we can get the vulnerabilities through internet if internet is allowed and browsable on that private instance.
Correct. Correct. Yeah.
Okay.
So you're saying that people can just download anything, etc., right?
Yeah, maybe virus or any other thing can be downloaded.
Yeah. I agree with that. It's just that an option. We are just looking at good things here. Then you need to have specific controls in place, technical controls in place. For example, antiviruses, updates, patching, and other management controls in place. So when people log in, they just do not download anything on the machine. I remember when I was working, we had a lot of controls on what can be downloaded and what cannot be downloaded. In fact, there were a lot of blacklisted applications that we had listed them down, and they were pushed using McAfee Solid Core. And we also had semantic endpoint protection on the virtual machines. So there are various controls and measures that we as an admins then take it to create that multiple layers of defense. Now, yes, with internet, good things can happen, and we are just looking at good things. For bad things, we'll have controls in place. Yeah, right. Any questions, team? Nothing. How many of you feel that it's a lot for today?
I feel it.
I feel it. Okay.
Yep, good session.
It's good session today.
Yeah. So the whole object is to make it productive and just do as much knowledge transfer as possible. I have no intentions to confuse anybody. But if anybody is getting confused, I'm always opening up the room for discussions, for questions. So that ways you can always take a step back to the blackboard and start drawing things and start from scratch. No problem at all. But we are here to share things. Even it could be between yourself, or maybe there may be something that I may be learning out of the discussion between you and me. So let's keep the forum open and the enthusiasm open as well. Go ahead and do the labs. Come back with a lot of questions. Give me bouncers. And then we'll regroup tomorrow again, and I'll just make a list of things that we're gonna do tomorrow. Networks. So we'll continue the discussion on networks, because what I have seen is that the VPC in the networks is something that Amazon really loves. So they have given considerable proportion of weightage to VPC in the exam as well. So we have to talk more about networks. We just gave a gist about direct connect, but we'll talk more about it. We'll also talk about NAT gateways versus NAT instances. We'll then talk about VPC peering in the network section. So that comes under the network design section. We also have to talk about stateless and stateless firewalls. So we'll have to spin some of the thoughts under NACLs and security groups. So what's the difference between NACL and a security group? So that's something we must know. Then something under the network section which must not be missed is high performance computing, enhanced networking, and placement groups. So if we know these things, then definitely there's a lot we can cover in the exam. In continuation to networks, security is a key aspect. So that's a separate subject though, although they are linked up together. Security is very important, and we start with IAM on the directory services. What's Amazon has to offer on the directory services section. CloudTrail, how does CloudTrail help in auditing, and how is CloudWatch helping us in monitoring of services? So we'll also do some labs around it. How about keys? How do you manage keys in IAM, right? Keys for encryption, because there's so many times you referred about encryption. So how do I share the keys across accounts is something that we will take a look at. What else? If time permits, then we'll also take a look at elasticity and differences between elasticity and scalability in the later section. As always, I will save these files and upload it to the Google Drive in a folder called as Day 2. Please download the yesterday's video, because Google has given me like 15 gigs of free space, and I've used that extensively, and I'm done with my like 14 gigs, 14.3 gigs so far. So, and the conversion of today's video will take about 3 hours. So please go ahead and download that, keep it safe in your computer, because I'll be wiping that off. It's kind of life cycle I've got to maintain for that file to make place for the subsequent sessions. With that, I think that hopefully today's session has been informative to you.
Don't delete it today. Do delete it tomorrow. So give us enough time to download it.
Yeah, you got like 4 to 5 hours, because if I have to upload today's video, I need to make space. So the only way I can make space is by deleting that big file.
You can create another account and share that drive.
Thank you. Okay, so I'll wait.
Anyway, I have another question. It's not related to today's topic. If in case of DR in our on-premises DR, we do the DR by system admin, right, DBAs, and all, since we do the database replication at the database level, and it is done and being set up by the DBAs. However, in AWS, there is no such role for DBA and system administration. So how do we set up database replication in Amazon as far as DR is concerned? And what are the best practices to set up for DR?
So your question was, how do you set up database replication in AWS RDS and disaster recovery in RDS? Is that right?
Sorry, I got disconnected for a moment. Would you please repeat?
Okay, so I was saying that I was trying to paraphrase your question. Basically, you're looking or more inclined towards the database replication in AWS RDS, right? And as there are options available in Azure, probably it's not there in AWS RDS, is what you were saying, right?
No, my second question is different. What how should we implement data strategy if all my clients' account is in so if it is one
I really cannot follow it. I'm sorry, but is there any way you can type it?
Okay, no problem.
See, again, it is choppy. Okay, if your question is related to database replication in AWS RDS, I'll say that you do have the options to create read replicas in your AWS RDS. Right, you can create read replicas, and if something goes wrong with your write copy of RDS, you can then promote your read copy to a write copy. Then you can also promote, or you can also provision multiple databases using multi-AZ concept, where your database will be available in multiple availability zones, within a region. Does that answer your question?
Okay, sir. Yes, sir. Thank you.
Thank you. Thank you, team, for your patience and your kind cooperation today. Let's come back and talk about the new topics, learn something new tomorrow as well, and please do the labs, come back with questions. Thank you. You all have great night or great day. Take care, guys. Bye bye.
You.
Thank you.
Bye now.
Thank you. Bye bye.
Thank you.
Thank you. Welcome.
Thank you.
Thank you.